Hello and welcome back to GCSE Revision. Today we're looking at Physics Topic 6, which is all about the particle model of matter. So first let's start off by looking at density. So density equals mass in kilograms over volume in meters squared. So that means that density is measured in kilograms over meters squared. Density is a measure of how much mass is in a particular area, and this means it's used to compare how heavy certain materials are, because the mass is in the same area. So we're taking away the effect of area to look at the pure mass of a substance, so we can actually compare it with other substances, as they will be turned into things with the same volume. So we eliminate that, meaning the only variable there is the mass. So yeah, materials with closer particles are more dense because they got more particles in the same area, and that's why solids are more dense than gases, because gases have spread out particles with weak bonds, and solids have close together particles with strong bonds. So next, let's look at changes of state. So changes of state are reversible, such as melting and freezing, because melting is turning a solid into a liquid, and freezing is turning a liquid into a solid. This process can occur on the same substance. Sublimation is when a solid is turned into a gas, or a gas is turned into a solid, but this is particularly when liquid as a step is entirely skipped. So this is when there's like a rapid change in temperature that allows this to happen. So next, let's look at the law of the conservation of mass. So during a change of state, mass and particle amount always stay the same, so they can't change. However, particles become more spread out in heating reactions, such as one to turn a solid into a liquid or a liquid into a gas. So this is as bonds are broken and more energy is added, so it increases speed to the particles and allows them to rapidly spread out. So the heat in this is the energy provided, and that's turned into kinetic energy for the actual particles, which is known as internal energy, and that's the total movement of all particles in a system. So you need to remember the internal energy. And overall, because in heating reactions the particles are more spread out, that leads to a decrease in density. And for cooling, there's the opposite effect. It leads to an increase in density, because if you think about it, cooling something makes more bonds and it takes away energy. So if the opposite things happen to it, it has the opposite effect in a way. So next, the specific heat capacity. So this is measured in joules per kilogram per degree Celsius. So the equation for this is the change in thermal energy equals mass times specific heat capacity times temperature change. So and there's the symbols for it. The E just means energy, and the theta sign, which is like the O with a line through it, just means temperature. So the delta triangles mean change. So next, specific heat capacity is the heat required to raise the temperature of 1 kilogram of a substance by 1 degrees. And we can see this through here. Joules is the energy part, kilograms is the 1 kilogram part, and degrees Celsius is the temperature part. So yeah, the final temperature minus the initial temperature, that's one way of finding out the temperature change if it doesn't give it to you in a question. So next, let's look at what have we got next? Specific latent heat. So specific latent heat is the energy required to change state of a substance with no temperature change, meaning the temperature doesn't go up or down. So energy for the change in state, this is the equation, equals mass times specific latent heat, which is in joules per kilogram. So you'd literally just take the mass and times it by the specific latent heat to find out how much energy we need. So there are two types of specific latent heat. There's specific latent heat of fusion, which is from a solid to a liquid, or specific latent heat of vaporization, which is from liquid to a vapor or a gas. And it's important that this only happens in reactions in that direction, because that's the ones where we add temperature. It can't happen to something such as liquid to solid, because for that we're actually taking away energy instead of adding it, so it doesn't work in the same way. Next, let's look at the particle motion in gases. So molecules in a gas move constantly, they also move randomly, so there's no set order to their movements, they just bounce around. So increasing the temperature of a gas or increases the pressure of the gas. And this is because particles move faster, which increases the energy, as there are more collisions. Because of this, temperature is directly proportional to pressure in a gas. However, these things only apply when the volume is fixed, as when the volume is fixed, gases can't expand. If the volume isn't fixed, gases will just expand. This increase in temperature won't make any difference to the pressure because it will just take up more space anyway. So next, let's look at pressure in gases. So firstly, a gas can be compressed or expanded by pressure changes. This means by changing the pressure, we can make a gas go into a really small area or go into a really wide area. So let's look at the equation for this. So the equation for pressure in gases is pressure times volume equals constant. And the constant is always the same and will normally be given to you. And it will be given to you as an equation fully completed, and you'll normally just have to put a different number in one of them and change another number. So because the constant is always the same, that means that one of these two will increase and one of these will decrease. So here's an example. Say constant is 2, and pressure is 2 and volume is 1. And say you were to change pressure to 4, then you'd have to change volume to 0.5 to make it still equal 2. So the thing would always equal 2, meaning that one has to go up and one that has to go down. So PV is a constant. So for a fixed mass of gas at a constant temperature, so that gives us the conditions. This only works if the temperature is constantly staying the same. So increasing the volume of something decreases the pressure, as we've seen from that equation there. And this happens in no temperature change again, because you're getting the same force in a larger area. So that means the force has a much littler impact, and it's less likely for there to be collisions because there's a wider space. Also, work done on a gas increases the internal energy of the gas, because this causes the temperature of the gas to increase, which increases the speed of the stuff inside there, increasing collisions and so on, collision theory. So that was Physics 6 on particle model of the matter. Thanks for watching. That was Joe Bailey Revision. Goodbye. This is on paper 1, by the way, remember that.